Hello, class, and welcome to your preparation for Lab Day. So if you're in Prep Physics, this is going to be your Lab 1 pre-lab, but if you're in AP Physics, this is going to be, obviously, Lab 2. Your instructions are identical, with a few exceptions, which I will talk about when we get there. So, at this point, please pause, get out the following things, and then hit pause again. I need your lab notebook or a clean piece of paper. You'll need more than one. A pen or pencil. If it's a pencil, please make sure it is sharp. And a ruler. You're going to need a straight edge with centimeter markings on it. All right, so there's that. Moving right along. Open up your lab notebook to the next clean, unused page. This is going to be called Lab 1. Inelastic collisions. Underneath Lab 1 inelastic collisions, if you're writing this down, I want you to list the name of everyone in your group. Then you're going to write your hypothesis. Our hypothesis is that the conservation of momentum is true. What I said in lecture yesterday is true. That is our hypothesis. The total momentum from before each collision will equal the total momentum from after each collision. And our data will either say, yeah, this hypothesis sounds right, or no, this hypothesis does not sound right. All right, now, quick thing. If you're an AP, this is called Lab 2 Collisions. So, whichever title you write down, everything else is the same. Underneath hypothesis, you're going to write procedure. Now, I have a bunch of things that go underneath procedure. The first thing that goes underneath procedure is overview. Please write this down. This is a sentence description of your procedure, of what you will actually be doing. For each collision, I will find the velocity before and after for each cart. Using this and the mass of the cart, I will calculate the total momentum before the collision, the total momentum after collision, and the percent air. All right, let's stop here for a second. The mass of your cart, that's 0.5 kilograms. And the carts that I want you to use, they're in the cabinets along the wall that are locked. The sub has a key. You want to use the carts with the spring on them. You'll know the ones when you see them. They also have Velcro. This is an inelastic collision lab, so the Velcro is important. It's what's going to make our carts stick together. All right, underneath overview, still inside a procedure. So we're still under procedure. We just did overview. Next up is equations. I want you to list all of the equations we're going to be using in this lab. This is a new lab write-up format. I think it'll make things easier for you to understand, both when you're doing the lab and when you're looking back at your lab to write your conclusion. All right, the equations we're going to use is momentum is m times v. Also, that total momentum is going to be adding up all of the momentums. And, oh hey, we're going to need to find velocity somehow. And we're going to do that by using this equation. All right. Underneath that, you're going to have your setup sketch. This is your track. You're going to have the cart track, and you're going to throw the carts at each other, and they're going to crash into each other. You're going to try really, really hard to have the carts crash right here. Please draw this. Please label the 100 centimeter mark as the crash point. We got there. We got there. And these are what we're going to call timing zones. All right, now what happens here is you're going to have the cart here, and you're going to push it. It's going to enter the timing zone, and you're going to hit start. It's going to leave the timing zone, and you're going to hit stop. that time you are going to use to calculate the velocity using this equation. Because if you notice, 40 to 90, that's 50 centimeters. That's 0.5 meters. 110 to 140 is also 0.5 meters, 50 centimeters. So that is how you're going to be getting your velocities. You are going to be measuring the time and calculating the average velocity. And it's going to be really, really close, so good enough. That said, if a cart stops in the middle of a timing zone, you have to redo the entire trial. The cart has to go all the way through the timing zone for you to get a velocity. So if it doesn't, you've got to do it again. All right, so now, how to find velocity. I want you to write down these instructions as well. It just says exactly what I just explained to you. When a cart enters the timing zone, you will start timing. When the cart starts to leave the timing zone, you will stop timing. This time is delta t. Both timing zones have a delta x of 0.5 meters. Plugging these two numbers into the velocity equation gives you the velocity. So that'll give you the velocity of cart A before the crash, or the velocity of cart B before the crash, or the velocity of both carts as they're stuck together after the crash, or whatever. All right. Today, in prep physics, you're going to do 3 collisions, all of them inelastic. In AP, you're going to do 3 inelastic collisions and 3 elastic collisions. More on that in a second. All right, collision 1. So please write down collision 1. What you have written down so far on your page is Lab 1, inelastic collisions. You have your names. You have a hypothesis. You have your procedure, an overview, the equations, and how to find your velocity. Now you have collision 1. Collision 1 is you're going to have cart A, and you're going to push it towards cart B, which isn't moving. That is collision 1. So cart A is pushed from the 20 centimeter mark towards the center. Cart B is at rest, meaning not moving, in the middle, so at about the 100 centimeter mark, such that its close end is on the 100 centimeter mark. The two carts stick together when they collide and roll away. So after the collision, it should look like that. All right, now we're going to have a lot of data tables, and they're going to be big. So listen carefully to this. Each column should be 1 centimeter wide. That's why you need to have the ruler. All right, so let's see. For each collision, you're going to do 3 trials. Data table 1.1. Data table 1, that's for collision 1. Dot 1, the first data table. The first data table for collision 1. The second data table for collision 1. We're giving them these names so you can refer to them in your written conclusion. All right, so that's going to be delta x, delta t, and VA initial, delta x, delta t, VB initial, and delta x, delta t, and V final. All right, now, cool thing here. This is 0.5 meters. I want you to write this down, but you're not going to use it for this collision. You got this. This will also be 0.5, 0.5, and 0.5. To find the before velocity, you're going to be using, let's see, it's 40 to 90. To find this velocity, you're going to use 110 to 140. Sorry, math, not working. 160. Aha! All right, there we go. That's how math works. So, data table 1, 2. Again, trial 1, 2, 3. What do we have? We have MA, VAI, PAI. The I stands for initial, in other words, before the crash. We got MB, VBI, PBI. Alright, then we got P total. Then we have MA plus MB, the total mass after the crash. The final velocity after the crash. And the final momentum after the crash. And then percent error. You're going to be doing a percent error between this and this. Alright, here's collision 1. Same exact story for collision 2. Except, different type of collision. In this, you're going to have cart A and cart B, and you're going to push them at each other such that they crash and then stop moving. Data table 2, 1, the first data table for collision 2. Labeling it the same. Except this time you're not going to use this bit. Delta X is going to be 0.5 for the entire time. Again, this is going to be 40 to 90, and this one is going to be 160 to 110. Alright, and this is going to look identical to this one, so I'm not going to rewrite it. Collision 3. You're going to have cart A, and you're going to push it. Then you're going to wait an instant, and you're going to push cart B way harder, so it goes faster. You still want them to collide at the 100 centimeter mark, such as they collide and are still going to the left. Alright, again, 1, 2, 3. Delta X, delta T, VAI, delta X, delta T, VBI, delta X, delta T, and V final. This one's hard because you get to cross nothing out. Where over here, you had 1, 2 times, so you need 2 timers. Use cell phones. Here you have 2 times, so 2 timers. Here you have 3 times, so you will need 3 timers. Where, again, this one is going to be 40 to 90. This one is going to be that's what my notes say, but that's still wrong. Oh, I fixed that earlier, didn't I? There we go, 160 to 110. Alright, and then over here is going to be 90 to 40. Alright. Again, this is completely identical. Alright, so let's go ahead and fix the small error that I made. It's here. See this here? This needs to be 50 big, which means that going to go to there. Which means that don't push it from the 160 mark. Please push it from the 200 mark. Push it from the 200 mark. And there we go. All right. For prep physics, you are now done. But here's a little demonstration of what the collisions will look like. Collision 1 is going to look like this. Whee! Crash. Whee! Collision 2 is going to look like whee! At the same time, whee! And then they're going to crash. And nothing's going to happen. And then for this one's going to go whee! At the exact same time, this one's going to go whee! Way faster, and they're going to crash. And then they're going to go up this way. Awesome. Prep Physics, you are now done with this video. Stop watching. AP Physics, keep watching. Collision 4. You are now in the elastic collision section. You're going to do everything the exact same way, except this time, instead of using carts that have the Velcro-y bits, you're going to use the carts that have the magnets in them. You can't push them too hard, because they'll still crash. You want them to just push away from each other because of the magnets. Alright, so for this one, all I'm going to give you is a sketch. You have to write me a description. You need to fill in all the data tables and collect everything as necessary. Notice that data table 4.2 here has some extra columns. That's a hint. Alright, collision 5. You're going to do this. You're going to write a description. You have to fill in all the data tables. Collision 6. Alright, this one, you're going to use the first typed carts again. You're going to get one of the carts with the springs, and you're going to put them right next to each other. So a spring cart and a magnet cart, so they don't stick. Then, one of them has a little button on it. You're going to push that button. The spring will eject them away from each other. Write me a description, fill in the data tables, do everything. Alright, I believe that is it. You are all ready to go. So, go!